Okay. It's cool. It's cool. I think nobody is chat is private also. So I think I have joined there. Let's wait for others to join. Okay. I think
Yeah,
push on the notification also in Bhaba. This is Bhaba batch, right?
Yeah.
Cool. Awesome. Okay, Gopi. So cool. Let's connect there. All the best. Okay. Take a deep
Sure.
breath. Take water. Okay. Don't need to worry. Take the one. The trick is, I'll tell you the trick. The trick is speak
Yeah.
slow and
Okay.
engage with the class. I think 3 people are there now, right? Including me. Cool. Okay, Gopi. Chalo. I'll be active in the chat. You can see there. Okay. Chalo. Bye.
Sure. Yeah. Thanks.
must be.
Hi, good evening, guys. So I'm Gopi Krishnan. I'm currently working as an instructor with the Attain U. So I'll be here handling today's class. Guys, you're able to hear me, right?
Yes, sir.
Yes.
Okay. Okay, that's great, man. So yeah, let's begin the session. Before that, give you a brief introduction about myself. So as I said, my name is Gopi Krishnan, and I'm currently associated as an instructor at Attain U. And in the industry, I'm working as a full stack developer for a company called Everledger. It's a blockchain-based company based out of United Kingdom, UK. So I'm really passionate about teaching. So I ended up in Attain U to get connected with you guys in order to pass on the knowledges that whatever I have learned through and whatever I had so far. So I have been in association with a lot of students. I have trained a lot of students before. So nearly around 50 to 60 guys. And each one of them are right now in a very good high tech companies with a very good salary package ranges, packages. So starting from, you can say around an average of 8 to 10 lakhs and more than that, depending upon their scales. Yeah. So yeah, it's a basic intro about myself. And yeah, guys. So I guess we'll start rolling. We'll start our session to move forward. Okay. You guys are able to hear me loud and clear, right, guys?
Yes, sir.
Yes, sir.
Okay, cool. Yeah, and small thing before moving on to the class. Uh, let's keep everyone be in mute. And if anywhere guys feel a problem, just ping me on chat. I'm actively looking into the chat on my another screen. So whatever questions you got, wherever you got, ping it on. Stop me there. Stop me right there so that I can take up your question. I'll re-explain it again and again. So until unless you people are clear with the concepts. Okay. Yeah. Let's maintain a bit of decorum. Follow this decorum. Okay. In case if I'm not able to check your chat, just raise your hands so that I can look into it and answer back whatever questions you have, guys. Okay. Sure, guys. Okay. Okay, cool, guys. So let's start with our session today. So today my screen is visible, right, guys? You can answer me back on the chat. Yeah, cool. So today we'll be looking into the system design fundamentals, and we will look at brief about how the big billion sale in Flipkart or Amazon works through it. Okay. So the topic that we are going to discuss today would be starting from what is an internet, then what is a system, then why we have a system designing, then we'll look into, and after this, most of the terminologies might be new to you guys. Each and every terminology I will explain to you. Each and every word that you are seeing on the screen will be explained thoroughly. So don't worry about it. Okay. So let's jump to the very first topic that we are going to discuss is about internet. Okay. So I'm pretty much sure that you guys have followed internet. I mean, you guys are using internet. So what is your views on internet? Can you people tell me what internet is for you guys?
A network that connects all the devices.
Okay, a network that connects all the devices. Acceptable. Any other answers, guys? Okay. Okay, fine. So internet is an yeah. Anybody? Okay, cool. So yeah, let's jump in. So internet isn't, you can say it's a broader network where lot of peers get connected and communicate with each other. Okay, and the peer you can tell here is it can be your mobile phone, your laptops, your any kind of electronic devices that you want to get connected to a particular network, and from there you can transfer or accept informations. And this informations are nothing but a data that you're going to exchange. Like if you go to Google and search for certain thing, like you go to Google and search like attain you will get the list of sites which have the particular word called attain you, right? So this is how an internet works. So this internet has a very beautiful history which started around early 2000, and most of the companies, very big companies like Google, Microsoft, Amazon, they started building products around the internet, and today it's a very big business, right? So they are employing a lot of software engineers today. So in this particular course, so the course that we will be having for the next 7 to 8 months, the complete course would be the full stack course, right? This full stack course is very, I mean, I'd say it's a very important course today in the market. Lot of engineers are, a lot of placements are going on with the full stack course. So I'd say you have chosen a very good career path right now. So I am here for you guys from top to bottom, each and everything. I'll be guiding you. I'll be training you guys in order to get into a very good company. So feel free to get back to me whenever, whatever doubts you guys have. Anything. I mean, you have a very simple doubt, a silly doubt. Don't worry about it. Get back to me. You can ask me a doubt so that I can reply back. I can understand your doubt, and we can work together in order to enhance your skills and bring up a very good skill set for the companies, right? You guys are with me, right, guys? Cool. That seems perfect. Yeah. So feel free to ask me any doubt. Okay, fine. So let's start up. Let's go deep into the concepts that we are going to learn today. Okay. So yeah, the very first one is internet. Internet is nothing but it's a network, a very big network where lot of computers get connected and exchange information between themselves. Example, you have WhatsApp, your friend has WhatsApp, you connect it through an internet, you exchange messages between yourself, right? This is a pretty basic example of an internet. Okay. So as we have seen internet, now we need to understand how this actually it's working out. Okay. Just give me a minute. Yeah. So let's talk about what is a system and how internet is connected to a system. So we had talked about internet, and we have devices which is get connecting to the internet, and each devices is going to send a data and going to receive a data, right? So that devices need to be programmatically kept in such a manner that we will get data and also send data. So that is called as a system. System is nothing but it's a group of device or computers which sit together to achieve a certain goal. Okay, system is nothing but a group of devices or set of computers which are going to be combined together so that they can achieve a certain goal. That is called a system. You guys able to understand what a system is in system designing?
So can you just repeat one more time?
Okay, see. So system is nothing but it's a group of computers or group of devices which are which communicate in between themselves in order to achieve something. Okay, so for example, you have a Google search engine. You take your mobile phone, you go to Google Chrome app, you search for Attain and you will get list of pages which has the Attain word, correct? So whenever you request for something from your mobile phone, when you search something in the mobile phone, I mean in the Google Chrome app, there are certain computers sitting in background which are going to search for that Attain They will find which are pages are there with that particular word and send that list back to your mobile phone. And this complete process is you can consider as a system. You're able to understand, guys?
Yes, sir.
Okay. So this is how a system is. So let's consider we have a small business. Okay, a small business where we have a website in the internet. Okay, this is you can consider as a Flipkart. Okay, this is the Flipkart website. So you log into the Flipkart website, you search for something, right, and you'll get the list of results. So what actually happens is that there are a list of computers. Okay, and these computers are sitting in the background. We will call this as C1, and then C2, then we have C3. Okay, so whenever you search for something called as like you're going to search for Alexa here, Alexa device. Okay, so this will go to each computer and ask for the result. Okay, I'm sorry. Okay, and ask for the result. So these three computers or any one of the computer will respond back. Tell that these are the list of devices in the name of Alexa. Okay, that will get listed in your web page, right? You will select any one particular item and you will buy it. So this complete setup, we can call this as a system. Okay, so when we talk about this is what a system is. This complete setup is called a system. So there are two types of system predominantly we are going to speak about. The very first one is called as a centralized system. The another one is called as a distributed system. Let's see what centralized system is and what a distributed system is. Okay. Okay. So let's consider this is a one person who is going to use a Flipkart website. And there is one more computer in the background, which is going to send the result back. Whatever the person is going to search in the Flipkart app, that result, it's going to get it from another computer and come back. So we have a central computer sitting in background, which is going to deal with all the requests. Let's consider during Big Billion Sale, there are a lot of people accessing their mobile phones or the computers to search for different items. So everything is resulted by a single computer. Single computer is going to handle this all the load. So this you can call as a centralized system. You guys understood what a centralized system is? Give me a thumbs up or yes in the chat so that I can move forward, guys. Okay, great. So this is called as a centralized system. So do you guys think there is any problem with this system here? Whatever diagram you're able to see, will you able to imagine and tell me what is the issue here it might come?
सर एक ही डिवाइस पे पूरा लोड आ जाएगा.
Okay, yeah. So एक ही device पे हर जगह पे load आ जाएगा. So this we can called as a single point of failure, correct? Because we have only single point. So all the devices would be hitting at the same location, right? You have one app, you have multiple apps here, and you have this one big system which is going to respond back, right? It will ask for something, this will reply something. Similarly, this will ask for something and this will reply something, right? So when the number of devices here, right, this will go on increasing, and during a Big Billion Sale or something, there are thousands, lakhs of customers coming into the website. So at that time, it is definitely the system is going to fail. And there is a good study. Very first time when Flipkart launched Big Billion Sale, right, that time the system went down because there were a lot of people coming in and they were not able to handle the request, right? So this is called as a centralized system. Okay, then let's okay. So next one is called as a distributed system. So we understood the problem. A single point of failure started happening because only one system was there to respond to all the systems. So what they did was they started increasing number of systems. Instead of one system, they break down into small systems, so that all the system, whichever system is available, that will revert back to the respective client. Okay, so this they called it as a distributed computing or the distributed system. So there are a lot of small computers available, which is going to respond back to tell them that, yeah, one person can handle the request with one computer. The another will handle the request with another computer. So there are a lot of computers available. There are a lot of people. So they were able to manage it. So this is called a distributed system. So you guys understood what a distributed system is?
No, sir. Can you repeat distribution system?
Okay. So distributed system is kind of something like this, where there are a lot of people coming in with a lot of devices. So there are a lot of devices which we have. Instead of one device, we have a lot of devices, which is going to reply back. So each one device will handle different processes. So you will distribute the work between a lot of people, a lot of computers, so that you can handle a lot of requests. You guys understood what a distributed system is?
Yes, sir.
Somebody asked me a question, right? They were able to understand?
Yes, sir. Yes, sir.
Okay, cool. So let's consider the big. Yes.
No, sir. You carry on.
Okay. So let's consider the same example of Big Billion Sale. Okay. So during Big Billion Sale, there were a lot of computers were there, and there are a lot of people were trying to access the data, and they were able to do it. Okay. So, but then a problem came. Can you guys tell me what a problem might come here?
सर कॉस्टिंग बढ़ जाती होगी.
That is number one. That is acceptable. Any other answers?
सोर्स जो है वो बढ़ जाएगा.
सर
ट्रैफिक.
ट्रैवल सर.
सॉरी, वापस बोलना सर, मैं सुन नहीं पाया.
ट्रैफिक बढ़ जाएगा सर.
Okay, traffic बढ़ेगा. Okay. Any other issue that you people think this would fail about?
सर ये जैसे कि पहले कौन आंसर देगा, जैसे कि कोई किसी की
Yeah.
डिवाइस ने पहले वो करा तो उसको पहले आंसर कौन देगा?
Exactly. So who will be handling whose request, right? So that would be a problem here. Correct. So let's talk about these things in detail in one by one slide. Okay. Okay. So let's move to the next one. Okay. So so this is I wanted to tell you guys कि मतलब as a full stack engineer, how you are going to deal with system. So there is something called as front end, which the user uses. Then you have something called as back end, the computers that are going to respond back with the information. Okay, then we have something called as database, where the actual data are stored. So as a full stack engineer, you need to design the system, the front end, back end, database. Okay, just the information for you guys. Okay, so yeah, so let's talk about the centralized system. We talked about the centralized system before. We got to know what a single point of failure is. Can anybody tell me what a single point of failure is?
सर टाइम ज्यादा लगेगा और लोड ज्यादा हो जाएगा।
टाइम ज्यादा लगेगा, लोड ज्यादा हो जाएगा. To solve that problem, right? To solve the single point of contact problem, what they did was they created like we have this one system. Okay, then we have multiple systems here. Okay, so the user will ask this system. Okay, then from here we will go to one particular system for now, and we'll get the result and come back. So let's not consider these two devices. We have only one device left. Okay, this device. When we have a lot of requests coming into this particular device, so handling was becoming difficult, right? So there were two solutions given by the engineers. One was called vertical scaling, and another one is called as horizontal scaling. Vertical scaling is kind of scaling where you will increase the size of the particular computer. You can increase the RAM, you can increase the CPU, you can increase the GPU, etc. So you people know what a RAM is, right?
Yes, sir.
Okay. So CPU and GPU, my people might be knowing. So in that case, what they did was, this was one small computer. So instead of that, they made a bigger computer to handle a lot of requests. By increasing it, RAM size was increased. Then GPU, CPU, everything, all the technical components in a computer was increased to handle a lot of load. So this is called as vertical scaling. Okay, to solve that issue, we found a way of dealing with it. So that is called as vertical scaling. So this helped small businesses to solve that problem. But you think the big business like Facebook, WhatsApp, Instagram will be able to solve the issue by this vertical scaling? Do you guys think that will work?
No, sir.
Also,
No. So in that case, what they did was they started increasing number of computers to send back the information. Okay, and that is called as horizontal scaling, where a lot of instances were created in order to manage lot of requests. And when this one particular example is called as what kind of system designing?
Distributed.
Distributed designing, correct. Okay, so now you people understood what a system is, how the system are classified, and what is the single point failure, and how to resolve the single point failure, right? These concepts you people are now clear.
yes, sir.
Yes, sir.
Okay, so that's nice. Let's move to the next part of the slide. Okay, so as we understood here in the distributed system, we got a very big issue, right? Like which person is going to handle which request, correct? Right? Okay. So that
Yes, sir.
was handled by a concept called load balancer. Okay. Load balancer is a nothing but it's a person or a middleware or a computer or a software. You can take it as anything. It's going to sit between all the computers, sit before all the computers, and it will distribute the work. Its job is to balance the traffic and distribute it across the computers which are available, who are going to respond back. Understood, guys? What this is? So whenever a person is going to make a, for example, the person is going to sit back and going to open his Facebook account. Okay, he'll be able to see all his notifications and all his Facebook page, right? So that data will come from which server, which computer? That will be decided by a middleman called as load balancer. You people are able to understand what a load balancer is?
No, sir.
No, sir. Okay, I'll explain it again. No worries. So in distributed computing, we had three major computers, right? For example, this is the main computer, which is going to make the request. Like I'm going to search for something in the Google text box. Like I'm going to search for cat. Okay. Okay. I'm going to search for cat, and I have lot of computers. And what is the scaling called?
Horizontal scaling.
Yeah, horizontal scaling. Okay. I have a lot of computers to result back. Okay. And similarly, I have other person who is going to search for dog. Okay. Other person is going to search for dog. Okay. Now I need to understand which one is going to reply me back. Right. So I will place one more device here. This is not an algorithm. You can say it is a device which is going to sit in front of all these computers, and everybody will request them. Okay. And this will see which guy is free, and he will assign it to them. And from there, it will get the response, and it will send back to the user. People understood what a load balancer is?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
Somebody asked me whether this is an algorithm. So I will tell you, this is a device, but the way it is going to assign it to a certain computer to process, that you can say it's an algorithm. There are a lot of algorithms available in the market. So depending upon what kind of load balancer you're going to buy, it will have certain algorithm. Okay. So there is some code running inside this load balancer, which will determine to which computer you need to ask. Yeah, exactly. It's just a load balancer. It's a device. Now you people are able to understand, right, what a load balancer is and how this is talking with different computers to get the result back. Okay, cool. So now you are able to understand, right, how this distributed system problem got resolved using a load balancer, correct? Is it a yes, guys? Okay, cool. So let's move to some of the basic theory part. Okay, this is kind of a theory part. Here in distributed system, we have certain characteristics. So in most of the system today available in the market, everything is a distributed system. Okay, and take any company, go for Google, Microsoft, Amazon, then Facebook, Tesla, then SpaceX, Flipkart. Every company have a distributed system because there's a lot of plus points. And let's discuss what are the plus points of the distributed system here. So a distributed system is really good. It has a good stability. It is also manageable. So stability, serviceability, manageability. All these three terms are synonymous. I mean, all these three terms are equivalent. What exactly these three terms mean is the simplicity and speed in which the system can be repaired or maintained. whenever you are talking about the distributed system, if for example, this one particular system has gone down, all the 4 other systems will be available to help to resolve this request. At the same time, you will be able to service the system and bring it back, right? So that is why this complete system is stable, and we are able to service it back and return it back to the system. That is why we are keeping it as a maintainable system, because we are able to maintain. There is no nobody knows whether some computer has gone down or not. Okay. So next one is reliability. Reliability is like you will be able to rely. Even something fails inside these computers, the other computers will respond back. So in a distributed system, it will respond back. If you consider a centralized system where you have a computer and you have one single point of contact, you will make a request and it will respond back. Okay. If this computer goes down, will be you people able to retrieve data here, or you will be able to make a request and get the data here? No, right? So you'll be not able to do it. So in that case, this is not reliable at all. So in that case, distributed system is reliable to us. This is an important characteristics of a distributed system. Then we have scalability. Scalability is like, if we want to increase the list of computers, we'll be able to increase it without changing the system, right? If I want to add 10 more computers to this pool, I will be able to add it. I don't need to disturb anything on the load balancer side or anything like that. I just had to add it and we need to configure it. That's all, right? If I want to change this one particular computer, then I need to remove this computer and put another computer here. In that case, it won't be reliable, right? So that is why the scaling becomes very easy in terms of distributed systems. Okay. Then coming to the efficiency or performance. Efficiency or performance, actually, here 2 things you can consider. One is the response time, how fast you're able to get a response, and how many requests you can make in a certain amount of time. So these 2 things you can consider. That one is called as response time, another one is called as throughput. Throughput is number of items delivered in a given unit of time. I'll explain it, what it is. Okay. So let's consider we have 2 systems here. Okay. So in the very first system, if I'm going to make a request with 2 clients, I mean, 2 people are going to make a request, one with cat, another with dog. The load balancer will choose whichever system is free, and it will respond back immediately. So two process can be done with 2 computers. So if, for example, this searching dog takes 1 second and searching cat takes 2 seconds. Okay. So the total time to complete the request and come back will be 2 seconds for cat and 1 second for dog. So this both will not affect each other. But when you have single computer, and first the person searches for dog, then he searches for cat, and that time the final result will take 1 plus 2 seconds. Correct? Guys, you're able to understand here what I'm trying to say?
Yes, sir. Yes, sir.
Okay. Okay. So this is called as the response time. Okay. Then let's talk about the throughput. Throughput is for, let's consider 10 seconds here. 10 seconds is the benchmark. And I will make n number of requests from these two or any number of people are trying to search for different animal names. Okay. In 10 seconds, I'll be able to cater a lot of requests, correct? If 10 people are searching, each take 1 second also. In 1 second, I can cater 10 people, right? You understood, guys, what I said here? Yeah. So in that case, for 10 seconds, I'd be able to resolve 100 requests. I'll be able to send response to 100 requests. But in terms of single computer, it won't be the same, right? For 10 seconds, you'll be able to respond only 10 things, right? So that is the throughput. We will fix a unit time. Inside that unit time, how many requests are getting a response is called as a throughput. So which will have a larger throughput, guys? You people understood or not?
Distributed system will have.
Yeah, distributed system will have. Right. So this is called as efficiency and performance point. Then let's move down to the next one. That is called as availability. Availability is, you can say simply, you can say, whenever I'm going to search for something, right, I need to get a result back. That means somebody who is going to sit back and send me the data. I mean, the computers which are going to send me the data are always available. So in terms of distributed system, there are a lot of computers available. So they will respond back. If one or two goes down, no problem. Others will respond back. But in terms of single point of contact, it is not like that. If one system goes down, it has gone down. We need to wait till that system comes back, so that then only we'll be able to process the request. So this is called as availability. So in distributed system, there are a lot of computers there. So if something goes out of working state also, others will respond back. So that is called as availability for distributed system. Okay, guys. So I know this slide is a lot of theoretical theory was there. So I just want to know whether you people understood each and everything, or do you want me to repeat anything, or do you want me to explain deeply something? Okay.
So
Others,
please
guys?
repeat the first point, stability and serviceability of manageability.
Okay. I'll repeat it. Any other doubt, guys, apart from this? Okay. See, stability of system. So see, this is a distributed system where I have a lot of computers here. Okay. So if for example, I need to every 6 months I need to service all these computers. These are machines, right? So I need to service them. I need to open it up, clean it up, and then put it back. Okay. So when I'm going to service each machine, so in terms of distributed computing, there are a lot of machines there. So I can shut down first two computers, and other computers can cater the needs of the users. Then I will bring back these two computers online. Then I will make these two computers offline. I'll make these two online. So at that time, I have only two computers are offline. So similarly, I can choose a batch of computers to service, and others will cater the request that the user is generating. But in terms of a single point of contact, if I want to service this particular computer, that is not possible, right? If I service this, there will be no computers online. So the servicing part, maintaining these things, it is very easier in terms of data distributed computing, distributed systems.
Got it, sir.
Okay, cool. So guys, I think we have covered a lot of concepts now. So do you want me to reiterate anything here, or shall I move forward to the next topic? Because next topic is going to be a bit more advanced.
So what's this fault tolerance and catastrophe?
I'll come to that. Thanks. I just missed that point. Okay. The fault tolerance is catastrophe preparedness. So you people know, right? There are a lot of, AWS, Google Cloud. You people heard about these terms before? Okay, AWS is nothing but Amazon Web Service. It's an Amazon company's biggest selling point. Okay, so I'll tell you why I have mentioned these words here. So let's consider in terms of distributed computing now. So I have, let's draw a fresh diagram now. Okay, so I have these computers, and these are two people who are going to search for cat and dog. Okay, this is for cat and this is for dog. Okay, I have a load balancer which will help me to search anyone. So my first computer, let's consider this as server 1. Computer is called server here because that is going to send back the response. Okay. Server 3, server 4, and you have server 5, and you have server 6. Okay. So this first server is based in Maharashtra. The second server is based in UP. The third server is in Andhra Pradesh. The fourth server is in Tamil Nadu. The fifth server is in Rajasthan. The sixth server is in Assam. Okay. So let's consider a problem, a big issue has come in India. There is a cyclone in Indian Ocean. So you can see Andhra Pradesh and Tamil Nadu in the coastal region. So these servers might go down, right? So this is the catastrophic coming in. So at that time, will people will be able to search dog and cat?
No.
Yes,
Why
sir.
they will
Yes,
not
sir.
able to search dog and cat?
Sir, the
Because-
server was down.
Yeah. So the load balancer will know, right? The server is down. So it will send that request to other server.
Yes, sir.
Yes, sir.
Okay. Now you understood what I made the point here.
Sir, if he want to search in AP and TN, then if
that-
servers will go down, then what will happen?
That is why we have distributed computing. So the person who is going to search, right? He doesn't know from which server is getting the response.
Sorry, can you repeat?
So the person who is going to search for something, right?
Yes.
He will never know from which server he is getting the response.
Okay.
The business, this is
Oh.
Google's business. Okay. The Google's business, they need to keep everything up so that the person, whatever is searching, he can get response back. Yeah. Any question, guys? I heard somebody were
So,
trying to say
yeah.
something. Yeah.
Sir, these servers are distributed in cities or they're placed at some place?
So these servers are placed. There are big companies, big data centers set up in different cities or on a local location connected through internet. It can be anywhere. Just it needs to be get connected to internet.
Okay, sir.
Okay. So that's what. So this is the catastrophe and fault tolerance. If let's consider, whenever a catastrophe occurs in multiple regions, there will be some servers in different places in order to cater the user's request. Okay. So this is what we called as catastrophe preparedness. Another one is fault tolerance. The fault tolerance, if let's consider this server is got affected by a virus. Okay. Now this 3 to 4 servers got affected with virus. There are still other servers which are safe. They can respond back, right? So whenever, that is why they have the backup servers. I mean, in different places in the country, not only country, all around the world, so that they'll be able to maintain the data and be able to serve the people. In turn, the other servers also go down. That is called as fault tolerance. Even there is fault with other servers, the complete system will be running. It won't stop.
हेलो सर.
Yeah.
सर ये जो सर्वर एक दूसरे से वायरलेसली कनेक्टेड रहेगा ना?
ये सर्वर एक्चुअली, ये पूरा जो सिस्टम है वो इंटरनेट के थ्रू कनेक्टेड होता है. It can be wireless, it can be wired internet, it can be metered internet, but it's an internet. The person who asked the question, you are able to understand?
Yes, sir.
Okay.
सर आपने मीटर्ड इंटरनेट बोला, वो क्या रहता है सर?
अच्छा, मीटर्ड इंटरनेट. ओके, मीटर्ड इंटरनेट कुछ नहीं होता, मतलब नॉर्मल इंटरनेट होता है जिसमें हम मतलब रिस्ट्रिक्शंस लगा के रखते हैं कि मतलब एक दिन के लिए इतना ही तुम यूज कर पाओगे या फिर खाली ये एप्स यूज कर पाएंगे इस इंटरनेट पे वैसे. ओके, दैट्स अ मीटर्ड.
नहीं,
क्या हम लैपटॉप पे देखते ना तो उस पे वो मीटर इंटरनेट
हाँ हाँ
लिख के आता था इसलिए
हाँ
पूछा
हाँ
सर.
yeah, because of that. Okay, it's limited. Okay, you guys understood till here, right? Clearly.
Yes, sir.
Yes sir.
Okay, I'll just give you a small this one. People get this okay, 1 minute. Sign in. Okay, fine. I'll move forward with the next one, that is Cape theorem. Okay, so यहाँ तक सबका okay है ना? Let's move to the next new topic. Okay. Is it boring, guys?
No,
No
sir.
sir, no sir.
Okay,
It's
I know.
interesting sir.
Okay, I know this is kind of a lot of theory in this. That's why. Okay. 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 So let's move down to the Cape theorem. This is a very important theorem, guys. I know I'm saying most of the components are important, but this is one of the important concepts because in interview, there is a chance that they can directly ask you this question. What is Cape theorem? Explain it. Okay. So you need to understand the basics of how this Cape theorem came up. Okay. The Cape theorem actually means consistency, availability, and partition tolerance. Okay. So here, what happens is in Cape theorem, these three things are very important. We will look into each and every word here: consistency, availability, and partition tolerance. Okay, the Cape theorem is nothing but it's an concept in distributed database system or normal system. Okay, where only 2 out of 3 are present. Either it would be consistency and availability, or availability and partition tolerance, or it would be consistency and partition tolerance. So Cape theorem is in these three in a system, only 2 can be only present. That is called as Cape theorem. Okay, let's see what this one things are. Okay, first one is consistency. Let's go back. Let's move down to a new diagram. Okay, so this is you can say a person A, and you have person B. Okay, and we have a load balancer here. Now the person is searching for something and asks the person this is server 2 and this is server 1. Okay, now person A is sending some data to store it in the database. Okay, so it will come here and it will come to S1, for example, for instance. So this will store person A's data. Okay, now the person A is again making a request to get whatever data he stored. At this time, the load balancer will send that request to S2. So will he able to get the data?
No,
No.
sir.
Sir, I'm little confused.
Okay. Yes, tell me.
Actually, the person is store some data in S1. Then after that, he also stores some data in S2.
No, the person one first sends a request to store a data. He is not telling anybody that it should be stored in S1. Okay. The load balancer deciding any one computer should handle the request. So very first time it asked the S1 to handle the request. So it stored the value as A here. The next time the user is making the second request. This is first request. This is second request. Now he is asking to get the data what he has stored. So that time the load balancer has sent the request to S2. So here the data is not present, right?
Yes, sir.
So
सर
this is
मगर
called
ये
as
इंटरनेट से कनेक्टेड है तो रहना चाहिए ना सर.
I'll explain that. Okay, so this is called as inconsistency. So what they do, what basically the companies do is they have a certain script, they have a little program here, okay, which will copy the data from S1 and put it in S2. okay, before sending the request response back to A. Or every 5 minutes or 10 minutes, they configure the time interval in which these data are copied from A to B, S1 to S2 or S2 to S3. In that case, when the first request is succeeded, at that time A is present here. Before the second request, the A also comes here. So this takes care of that particular thing. So now whenever the person is making a request, it will be present in S2 also. So to whichever computer it will go, the data will be present. He will get the data back, right? So this is called as consistency. You understood what a consistency is and inconsistency is?
Sir, repeat one more time.
Okay, fine. Let's make clear this. Okay, so the very first time the person makes a request to store a data, his data. Okay, so the load balancer selects S1 first, and here this request gets processed, and A is stored in S1. Now it will send back the response to A, stating that your data is stored, is successful. Whatever request you made, that is successful. Now A is again making a request to get the data whatever he has stored. At this time, the load balancer is sending that request to S2. S1 is busy with some other task, so it is sent to S2. But S2 doesn't have the data, right? So it will send back, there is no data available for user A. So this is the issue with inconsistency. So what companies do is they will write a piece of program which will sit in between here. So whenever there is a data gets into S1 or S2, they will copy it to the other servers also. So in this case, this will be A. So this is how the consistency is maintained in terms of S1 and S2. And you can, I got a question. So you will be able to understand who asked this question now?
Yes, sir.
Okay. So I got a question from, I got one more question stating, what if there are S1, S2, S3, S4, n number of servers? Okay, how
Sir,
to
I have a
maintain?
question.
1 minute, I'll just answer the question now, and after that I'll come to your question. Okay.
Yes.
Okay. So if there are a lot of servers there, at that time, the copying work will be done. It will done across the servers. That is why whenever consistency is very much higher, the availability of the S1, S2, S3 comes down because this copying mechanism is going on. Okay, that's why the availability comes down. Okay, I guess Preeti asked me a question. Okay, somebody were asking me a question, right?
Yes, sir.
Yeah.
सर ये जो सर्वर्स है
हाँ.
S2 and S1 ये अपन अगर लाइन से कनेक्ट करे तो मतलब वो जो अपने क्लाइंट जो ए है वो डायरेक्टली डाटा ले सकता है S1 या S2 से.
हाँ देखो, so see, don't think LAN, LAN, WAN, Wi-Fi, these are just medium of communication. उससे कुछ लेना देना यहाँ पे है नहीं, मतलब वो बस इंटरनेट प्रोवाइड करते हैं डिवाइसेस को, ठीक है? Who asked me the question? I mean, you were able to understand?
Yes, sir. Yes, sir. Swapnil.
Okay. So this is why whenever a consistency is much higher, the availability goes down. And whenever the consistency is less, at that time, all the servers will be free. So at that time, the availability will go up. So these three things are really, opposite. So maintaining a good balance between the consistency and the availability is what we engineers do. You guys understood what a consistency is and what a inconsistency is? Give me a yes or no so that I can move next.
Yes, sir.
Okay, fine. So this is a small definition that I'll just go through once. Consistency means that all clients means the person who are going to use the app, okay, will be able to see the same data at same time. It can be a number of people who are going to share same data from different servers, different nodes, doesn't matter. They will be able to see all the data at the same time. That is called as consistency. Then we have called as availability. Availability is, let's move to the new diagram now. So we have two people, A and B. Okay. And we have two servers, S1 and S2. We have a load balancer here. If A is making a request now, and load balancer is sending to S1 now. At the same time, B is making a request. So it will send it to S1 or S2. It will revert it to S2. This is happening at the same time. So the number of people who are going to make a request, so at their time, their request is processed without getting failed, is called as availability. Even if this S1 goes down, these two requests will be forwarded to S1. So one after one, it will be processed until the S1 comes back. S2 will handle the system. If S1 and S2 both goes down, at that time, we'll be adding a new system to the server, which will be called as S3, which will handle this request. So this is the availability part. So each and every user will able to process the request and they will able to get a response. I mean, any one server will be there who will going to cater its need. So that is called this availability part. You guys understood what an availability is? Guys? Okay.
Yes, sir.
So I'll tell you a small interesting story here with Flipkart. What happened is, so Flipkart was actually having these servers, physical servers, during the Big Billion Sale. Okay. So after that, they converted these this physical servers into virtual machines. I mean, it is in the cloud. So they have hired some company which will be having these computers from there, and they will go and adding it. So at that time, Amazon came up with a very good solution. What they did was, if number of people making the request increases, depending upon the number of people, they will also keep on adding dynamically. They will be keep on adding the servers, so that no person will be going back stating that my app is not working or I'm not able to get a response like that. So dynamic addition of these computers is also possible today. So we do that to increase what kind of characteristics? So why do we add dynamic computers, guys? Hello.
To handle more load.
Yeah, to handle more load in terms of increase the availability part. Okay, and this is called this availability. Okay, then let's move down to the next one, which is called as partition tolerance. Okay, so partition tolerance is nothing but okay, let's move on to a new diagram. So partition tolerance is nothing but let me draw it once. Okay. Okay, so these two are two people who are going to search something like dog and cat. We have a load balancer, and there we have we have servers, and these circles are nothing but the programs or the script which is going to copy data from one server to other server, or these are the places with which they will communicate with these in between servers. You understood the diagram, guys? Guys, you're able to understand the diagram, or do I have to explain that again? Okay. So whenever
be connected, partition tolerance है ना?
नहीं, partition tolerance नहीं है. P is nothing but it's a program or some device which is making this S1 and S2 to talk between themselves.
Okay, sir.
Okay. So partition tolerance is nothing but in distributed computing, we have a large number of servers. So there is a chance that some servers might go down. There's a chance that these two servers won't talk in between. Okay, if A is sending a request to store A's data, now we are sending that to S1. Okay, this P1 which we have here, this should have copied the A's data to S2, but it didn't copy because this has went down. But at the same time, we have other P which will be copying data to the other servers. Okay. Similarly, we have one more program which will be copying data to the other servers. So this is it's a very comprehended mechanism to do this stuff. So sometimes it happens that these two computers don't speak to them. So this partition has been broken down. In that case, still if A's load balancer will know that this partition is broken, it will send a request to some other people in order to send the data back to A. So even this particular partition has gone down, no matter. We are able to respond to the A or B, depending upon the request, we are able to find data in other servers. So this is called this partition tolerance. You guys understood, or do I have to repeat it?
Yes, repeat one more time, sir.
Okay. A minute. I'm just trying to delete it. Okay, it's not happening. No worries. Yeah. So what happens is, so very first time A is making a request to store A's data. So load balancer 1 send it to the S1. So A is stored in that. At that time, some technical problem came. So it is not able to send the data to S2. So it has sent the data to S3 and S4. Because these two are not able to communicate. This two's partition has gone down. Okay, but we are able to store the data. Now A is again making now B or A is making a request to get the data whatever A has stored. So so the load balancer knows कि यहाँ पे नहीं है data. मतलब ये partition has gone down. So it will ask other servers to respond back, which will have the data. Okay, so this will respond back. This is called as partition tolerance because this partition has gone down. The complete system has tolerated that, and still they are able to successfully deliver what the user has asked. So this is called as partition tolerance. Guys, समझ में आया क्या अगर की है?
Yes, sir. Yes, sir.
Okay. Now your people are able to understand, right? What an Cape theorem is, and what consistency, availability, and partition tolerance is. Any doubts in this, guys?
No, sir.
No. Okay. So okay. Give me a minute. Okay, fine.
Hello, sir.
Fine. This is yes. Any
Sir,
doubt?
अगर अवेलेबिलिटी और पार्टीशन टॉलरेंस एक साथ रहेगा तो मतलब कंसिस्टेंसी नहीं रहेगा उधर.
नहीं रहेगा. हाँ, मैं वही भी समझाने के लिए आ रहा था. Yeah, exactly. Now we will talk about we know what a consistency is, what an availability is, and what an partition tolerance is. Thanks, Justin Bola. Very thanks for that. I will come to that now. Okay. So according to Cape theorem, in the distributed systems, we can have only two. We can't have all the three. Either it should be any two should be only there. Correct. So you guys are able to see the diagram, right? Okay, cool. So let's move to a new diagram. I know, guys, my drawing is a little bit messy, but you are able to understand, right?
Yes, sir.
Okay. Thanks. Okay. So guys, here, so let's talk about the very first one, partition tolerance here. So do you think, is there any possibility that any one system will not have a partition tolerance? Is it possible? Tell yes or no, guys. I mean, tell me your perspective, what you think.
हो सकता है
Possible hai, right? Yeah, that it is possible, but in real world, right, always there is some or other issue might come. Internet down हो सकता है, natural disaster हो सकता है, या फिर power supply का problem हो सकता है. There are n number of reasons to make this partition tolerance always be there. Okay, so generally people consider partition tolerance is one thing which can be always be present. It's generally considered because there are a lot of options there which can enable partition tolerance. Okay, then becomes for consistency and availability to get paired with partition or tolerance, right? Either it will be like these two or these two, right? So let's talk about the very first case where consistency and partition tolerance is there. In that case, we are not able to process between S1 and S2 because of partition tolerance. Now, but we need to be very, very consistent, very, very high consistent. In that case, when A makes a request to store A's data, it will put it down to S1. A is stored here, and this will send back the data to S3 to store it. S2 will not have the data. And similarly, we have a lot of servers, S4, S5, S6, S7, like that. Okay. So in that case, once the A makes a request, there are a lot of servers it needs to store the data, right? So in that case, do you think at the same time, if somebody else make a request, we'll be able to process that request? Because all the servers are busy copying the data. Do you think if that time B makes a request, will that be processed by any of the servers?
So available नहीं रहेगा.
Available nahi rahega. So what happens if consistency is higher, the availability goes down, right? So when partition tolerance and consistency are there, at that time the availability is going down, right? समझ में आया, guys? Do you want me to explain again?
समझ में आया सर.
Okay. समझ में आया ना? Sorry, मैं सुन नहीं पाया आप क्या बोले थे.
हाँ सर.
Okay, cool. So let's consider now second one where partition tolerance and availability is there. So in that case, this everything is working fine. This has gone down. Now at this time, if A is sending a data, A got stored in S1, but it takes time to get stored A. It takes some few like 10 seconds to store A in S3 because we are now not considering the consistency. We are considering about the availability. So we need to keep the other servers available for B to make a request. Before 10 seconds, if B makes a request, and it will send it to here. So A is not present here. So A will not get, if B is requesting A's data, it won't get it, right? Because it takes 10 seconds to get copied to S3. Or similarly for S4. So will it be able to get the data? Whatever A has stored? Guys?
सर
Hello?
रिपीट करिए सर ये पॉइंट.
Okay. देखो, first ये वाला केस आपको समझ में आ गया ना? Consistency and partition tolerance.
Yes sir.
Okay. Now next one is partition tolerance and availability. So here we are partition tolerance is there because S1 and S2 are not able to communicate, and now A is sending a data that to be stored in the server. So the load balancer selects S1 and S1 stores it. Now we need to maintain high availability of the servers. So in that case, the S1, the one which we need to send, copy the data between the servers, this will delay. इसको हम delay कर देंगे. क्यों delay करेंगे? क्योंकि we need to keep the servers up. So we will slowly copy between all the servers. So when we do this slow process, at the same time, before getting copied, if B makes a request of getting the data, whatever A has stored, so at that time, load balancer selects S3. In that case, will B will be able to get the data? Because
No,
A is
sir.
not present, right? So yeah, so it will not get it. So at that time, when availability is very high, the consistency goes down. Correct? You guys understood this point? Somebody asked me, right? You are not able to ask me to repeat, right? You are able to understand? Hello.
Yes, sir.
Okay, cool. So this is called as the partition tolerance and availability one. Now let's move down and talk about a new case, a case which occurs very less time. That is, there is no partition tolerance, but there is good consistency and good availability. This is very hard to achieve in today's environment. Okay, because all the servers are up and the same time the copying is happening at the instant speed. So that is one particular thing that is very not very common to achieve. Okay, so let's talk about that in a very good diagrammatic way. So yeah, sorry, I just left that case. I'll just talk that case also. So let's talk about these two cases where consistency and availability are there. Okay, now A is sending a request to store A. Okay, now we got A and we store it in B and C and D. Everywhere we are storing it. Okay, but at the same time, if certain node goes down, if this partition tolerance have come, this completes this will go down. This will go down. Similarly, one more partition tolerance comes between these two. This will also go down, right? So when consistency and availability are high, this partition tolerance is not there because we are not able to deal, right? Everything is connected. In that case, the complete system will go out of range. There will be a problem with the network. You'll be not able to send a response back to the users. You understood this special case, guys? The availability and consistency part without partition tolerance.
सर आपने तो कहा था एक नया सिस बना लेगा as
क्या मतलब? If something goes down, we will add one more system that you said. You're telling?
yes sir.
See, in every case that is not possible. If we have that kind of mechanism, then there won't be a problem. देखो, जब ये पूरा system down हो जाता है, तब हम एक और नया system add करेंगे, correct? When
Yes.
we are adding a new system, at that time, whatever data that these systems has, that needs to be in this system, right? जो ए का डेटा इस सिस्टम में स्टोर हुआ था, वो अभी डाउन हो गया है. अब जो नया सिस्टम ऐड हुआ है, उसमें तो डेटा नहीं होगा ना.
Yes sir.
So at that time this will fail, right? It will fail whatever it will give empty data, right?
सर एक दूसरे से लिंक भी नहीं होंगे ये सब.
कौन से ये आप नए सिस्टम की बात कर रहे हो?
नो यस सर, इनसे लिंक ही तो होंगे तो कॉपी डाटा नहीं कर सकते.
See, when all the systems have failed, at that time only this new system will get added in that case.
Yes sir.
So तब ये copying वाला mechanism काम नहीं करेगा. Even if it is copying data, it will take some time to get the data into this new server, right?
Yes sir.
Think about not about single data. Think about tons and GBs of data. Okay, it will take time, right?
Yes sir.
So there would be a network failure or empty response, correct? So this is why the CAPE theorem is very important, because only 2 out of 3 will work properly. Now if people are able to understand why the CAPE theorem states that only 2 can work properly if all 3 cannot work together. Guys, am I clear, or do I need to explain it again?
Clear, sir.
Yes sir.
Okay. Okay, let's just reiterate it again. Okay, we have consistency, availability, and partition. So this is a CA category where consistency and availability both are there. In that case, there might be a network problem, as we discussed, because all the system can go down because of PT. Okay, so there is a other category called as AP, where availability and partition tolerance are there. So when partition tolerance and availability are there, there might be a chance there will be inconsistent data, because to maintain the availability of all the servers, the coupling mechanism might take some time. So that is why we might face this issue. Okay, this is called as inconsistency of data present because high availability is high. Then we have CP category, where we have high consistency and partition tolerance. In this case, when consistency is high, there is a chances there some of the servers might not respond back correctly because availability goes down, because there are a lot of servers are busy getting copied, right? So these are the three categories that we need to learn in terms of Cape theorem. So guys, any doubt in Cape theorem or consistency, availability, or partition tolerance that you want me to explain back?
हेलो सर
Anyone? Sorry.
सर हमें
Yeah.
CA को ज्यादा प्रेफरेंस देना चाहिए या CP को?
हाँ देखो, तो मोस्ट ऑफ दी अभी आज के डेट पे मतलब बहुत सारे यू टेक द कंपनीज राइट, they depend upon the users, the use of their product, right? They select which kind of thing they need. Let's talk about one live example. You know Facebook, right guys? Facebook.
Yes sir.
Okay, there are two people who founded Facebook. One was Mark Zuckerberg, another one is Mark Zuckerberg, and another one was Eduardo Saverin. Okay, so initially the Facebook's idea was to connect people. Okay, connect people. So Mark Zuckerberg wanted Facebook up all the time, means every time anybody logs into Facebook, it should work fine. Okay, but Eduardo Saverin wanted to make money in Facebook, so he wanted to put down a lot of ads in it, from which we can get a lot of data. So when you put a lot of ads in it, the you'll be able to be the availability of the system goes down, because there are a lot of connections with the ad system. If Flipkart is going to come and put ad, we need to connect it to the Flipkart, then Amazon, like that. So at that time, the availability has gone down because of that. And when there was no ad, that time availability was very high. Okay, so depending upon the use case that you're going to work on, or the company that you're working, or which product you're working, depending upon that, we'll be able to decide whether we need to work on CP or AP or CA. So each company has different target. Okay, guys.
Yes sir.
You people understood, right?
Yes sir.
Yeah. I'll give you one more live example. You know ambulance, right? So whenever a person calls hospital, okay, this is user A, he calls in hospital, or he calls 102, which is an ambulance service. Okay, and this has a lot of hospitals connected to it. Let's say H1, H2, and H3. Okay, this particular, I'm not sure whether it's 102 or 103. Okay, just bear with me. Okay, so when we call the ambulance service, they will check which hospital has the ambulance depending upon where the user is located, and they will ask that particular hospital to send it. Okay, so now for these hospitals, what is their main motive? They need to be available all the time, right? So availability has a higher priority here. Okay, there will be situation like when you're calling some other service, there will be situation where the availability is not that much required, but the data consistency will be very, very up. So for that, you can take an example of IRCTC train booking service. Okay, so there is a website there we have different service in service where we book train ticket. So similarly, this user is making call to the IRCTC website. Okay, website. Now you can see during peak season, you are not able to access the IRCTC website because all these servers are busy in consistency the data. So you have a train say 101, it's a train number in which all these 11 seats are getting filled. So all these seat data needs to be maintained in all the servers. Then only they can book correctly, right? So in this case, the consistency plays a major role. You guys able to understand what I'm telling here?
Yes, sir.
Okay, now you're able to clear, right? I mean, how to choose categories.
Yes, sir.
Okay. Okay, this is all about the CAP theorem, guys. Any doubts, anything that you want to clear me, get cleared? Hello? Hello?
All clear, sir.
Okay. Cool. Okay. Let's move to the next.
सर ये MongoDB, HBase जो सब नीचे लिखे हो सब
हाँ।
database है ना?
हाँ, सब databases है, वो मत देखो please. मतलब I have taken this picture from internet, so it also came with that. Okay, I don't want to confuse you guys with that. Don't think about that. Okay, these are databases. Okay, guys. Hello.
Yes, sir.
Okay. Fine. Just give me a minute. I'm just posting MCQs for you guys. Okay. Session create. Sorry. You people know, right? You people get MCQs, right? Okay. Just pasting the very first question. Okay. Are you guys able to see the MCQ that I have posted?
Yes, sir.
Okay. I know this is a very simple question. Try answering it fast. Okay. Okay. I'll just leave it to that. At the same time, I'll just move to the next one that we want to discuss. Another one is latency. Okay. So latency is okay. You're able to see my screen, right, guys? You guys know about this Black Friday sale? Anyone knows about this Black Friday sale? It is a sale that happens in US, Singapore, UAE, where a particular Friday in December, it's called as Black Friday, because all the technological items comes for very, very cheap, nearly 50 to 60%, 70% offers are there. Okay, so this is called as Black Friday sale. Okay, so for example, if I am a person who is going to access Amazon's website in US to order something for me, I mean, not order something to my relative who is there in US, so that he can bring it back to India. Okay, so in this case, what I will do is, I will, from India, I'm going to access Amazon site in US site, Amazon's US site, and then we'll select certain thing and order something. Okay, so what I need to do is, from India to USA, I need to travel through internet. Whatever search I'm doing needs to travel through internet. So it needs to pass through lot of routers. The circles you're able to see, right? These are called routers. Router is nothing but it's a device which will direct it into the the respective request that you are making to the correct location. So this is like you can consider as an airport. So you go to Indian airport, like you go to Delhi airport or Mumbai airport. You take a flight, you reach London. From you get down at London, then you change flight. From there, you take a flight to New York, and then you reach USA. Okay, so you can consider this airport just the routers who are there to connect you to the correct location. Okay, this is called as routers. Okay, why I'm telling is this is because in India, if the server is present in India, you're able to get the response very fast. But if the server is present in US, it takes some time to go there and come back, the request and response. And that is called as latency. You people understood what a latency is?
सर रिपीट कर दीजिए एक बार.
हाँ, कोई प्रॉब्लम नहीं. देखो, latency का मतलब होता है when a person makes a request. Okay, I'll draw a diagram, no problem. There is a person called A who is going to search for cat. Okay, and we have server, one in India and one in USA. Okay, so when the user is in India, okay, the user is India. So when the user makes a request, if the load balancer sends it to the Indian server, it is nearby. He'll be able to get the response in seconds. I mean, in seconds, right? In 1 second, you'll be able to get the response. This is true, right? But if the load balancer chooses some results which is coming from USA, so there are a lot of routers in between. Okay. So this request needs to go from 1 to 1. Then finally it goes to USA, then comes back. So this will, because it's a long distance and the path that request needs to travel is longer, that way it may take some 2 to 3 seconds. So this is called as latency. The latency is when you subtract this to this, the latency is around 1 to 2 seconds. You can see there is a latency of getting the response back to the user. Now you people understood what it is?
Yes, sir.
Okay. Somebody who asked me, yeah, Pradeep, you have a doubt?
Sir, can you show us live example, change your server to some other country and can show?
Okay, I'll do it at the end of the class then. Okay, I don't want to mess it up the class. I'll definitely do it for you. I'll create a live example and show you. Okay.
Yeah, okay, sure, sir.
Okay. Because I don't want. I mean, if I do it right now, right, there is a chance that I might miss the class or something might go wrong, right? So,
Oh,
yeah,
okay.
that's why. Okay.
Yeah, okay.
Because this is my first class, I don't want to mess it up. Sorry. Okay. Yeah. Okay, I'm posting a next MCQ. If people can look into that and tell me whether, you can answer those questions. Okay, so you're able to understand, right, what an latency is? If it is a yes, I will go to the next topic, guys.
Yes, sir.
Okay. Cool. And yeah, before going that, I need a few things to clear in latency. Okay. So in latency is always, it's near to zero. It's not that much big, but it's always near to zero. It would be around a few nanoseconds or microseconds like that. Okay. There is one more term that you need to guys to look into. That is round trip time. The round trip time is nothing but the total time taken from the user issuing a request. It goes to load balancer, goes through the routers, goes to the server, and then gets the response and comes back all the way back to the user. So this complete time taken to travel from the client to the server and bring back the response from the server to the respective client is called as round trip time. Okay. People understood, right? What an round trip time is? Hello.
Yes, sir.
Okay, cool. So this is all about the round trip, the latency part. Now let's move to something called as SLA. Anybody know what an SLA is? Anybody previously heard what an SLA is? Okay, SLA is called as service level agreement. Okay, this is called as service level agreement. S stands for service, L stands for level, and A stands for agreement. This is an agreement generated by the techie, the business and techie peoples inside a company, so that they can make a deal with the user who is going to use their product. Let's consider you have a product like Google Cloud. You are aware, you people know what a Google Cloud is?
Sir, online
That's-
storage.
Sorry, I missed
Sir,
your guys. Can
online
you
storage.
The server product
Storage.
provider है.
Server storage.
Yeah, it's an Google Cloud is nothing but it's a cloud service where you can create servers, you can deploy your applications like that. Okay, so in Google, there we have database where we can store the data, and there are a lot of users who are going to create. You can consider this as business users. These are business users. Like for example, this is an business like Flipkart. Then you have Amazon. Then you have one more like eBay. Okay, so these guys, I'm telling for example, they are not storing data in Google, but I'm telling as an example. So these guys have created different tables in databases in Google Cloud. Okay, GCP, Google Cloud Platform. Okay, now these guys will store the data in respective databases or the servers or the database. So there are a lot of users in around India or around any place. They are going to hit either Flipkart or Amazon or eBay like that. Okay, so these guys are hit it. So they will get the result from the GCP and send back the data to the respective users. These are users. Okay, so they will send it back. So the Google Cloud, this Google company will make an agreement with the business users like the Flipkart, Amazon, eBay. Like what they will do is they'll create agreement. It's a service level agreement which will tell that if you are going to hit our service and I'm not able to respond back in this amount of time, then I will give back your money. So as for GCP, right, if 99 to 100% time, okay, 99 to 99.99, okay, if that amount of time, if any request is failed, right, it will pay back 10% of the amount whatever the business have paid them. And similarly, if 95% to 99%, if requests are failing, in that case, the 4 to 5% the requests are failing, they will pay back 1/4 of money, that is 25%. And if nearly 90 to 99%, 9 to 10% of requests are failing, they will not charge at all. So these kind of agreements are made, and these agreements is called as service level agreement. You people understood what a service level agreement is, guys? Hello. Anyone say yes or no at least?
एक और बार बताइए.
हाँ, okay. ठीक है. देखो, there are a lot of business. They are going to use GCP. Example like GCP. Okay. In this case, they need to these servers needs to be available according to Cape theorem. They should be always available, right? The availability should be high. In case if they are not available, like 0.1% to 1%. If they are not available, whatever service charge that GCP is taking from Flipkart or Amazon or eBay, they will refund 10%. If they are not available for nearly 1 to 5%, then nearly 25% of the money, whatever GCP has taken as service charge, they will return. And if they are not available for more than 5 to 10%, then they will not at all charge anything, because this becomes their problem with their brand, right? So they need to be really very, very highly available for their customers. So these kind of service, the agreements are made, and that is called a service level agreements. Abhi samajh gaya hai?
Yes, sir.
Okay. So this is called as service level agreements. Okay, cool. I am posting one more. Okay, I'll post it last. Okay. So this is all called as SLA, this service level agreements. Okay. So you guys understood, right? What a service level agreement is? Okay. So let's move down to the very last topic that we are going to talk about today, is stateful and stateless system. Okay. So we have one system, one user, and we have a load balancer here. Okay. Then I have two servers, S1, S1 and S2. Okay. And this is user A. Now he's making a request to store his data. So this system is highly available. Okay. Availability is higher and consistency is lower. Okay. In this case, the data, it selects S1 and it stores S1 value of A here. Okay. Next time when the user asks for the data in the request 2, it checks with S2, and so it will get nullous response. Correct? In this case. Hello.
Yes, sir.
Yes, sir.
Okay. So let's consider this as the first one. There are two types of systems. One is stateful system and one is stateless system. In stateful system, the user's data is recorded. With user's consent, it is recorded somewhere. Apart from the database, it is recorded somewhere. Okay. In stateless system, no user data is recorded. It is not recorded at any place. Okay. Let's talk about the example. If see the load balancer here we have. So now the load balancer know that data of A is stored in S1. So it will create a small memory. It will say S1 has responded to user A. So the next time when the user A makes a request, at that time the load balancer will wait and will send the request to S1 only. So that is based upon this information, which is it's storing it inside. So this is called as stateful system, where the user's data is recorded somewhere with which intelligent decision can be made. That is called as stateful system. If people understood what a stateful system is? Do you want me to repeat, guys?
Yes, sir.
Yes, sir.
Okay. So I'll give you a live example. Okay. So let's consider you have Flipkart. Okay. Let's consider Instagram app. There's a lot of Flipkart today. Let's talk about Instagram app. You have a search button at the bottom right in your Instagram app. Once you click on, the search bar opens, right? So previously search results, where are you able to see it in the drop down? You're able to see the search results, right? Previously searched values.
Yes, sir.
Yes, sir.
Okay. So these data is stored somewhere in your mobile phone, correct? Or in the server somewhere, right? Whatever you have searched previously, right? So these data are stored in your mobile phone in the local storage. It's stored somewhere. Okay. Similarly, in case of Google Chrome, if you're in the Google Chrome, when you search something, right? Yeah, you can see the list of searches that you've done before. And these data are stored in cookies. Cookies are nothing but it's a piece of program which is sent by the server, like S1, S2. This is sent by the server on the user's browser to set it so that they can track the user. Using cookie, we can track what the person is typing, what the person is doing in the website, or what he has searched before. So these data are stored in the browser's cookie. Okay, and with that, you'll be able to get this data. So storing it somewhere to make an intelligent decision, that is why it's called a stateful system. The people understood what a stateful system is now?
सर रिपीट करिए एक बार और.
ओके चलो देखो तुम्हारा गूगल क्रोम है, यहाँ पे आके तुम कुछ सर्च करने वाले हो. लेट्स टेक अ लाइव एग्जांपल. See, if I'm going to search something, you're able to see the list of searches here, right? Which was previously I have done. Before this class, I was learning about these things. I mean, I was refreshing my topics. So I have searched these things. So I'm able to see it here without even my consent. These data are stored here. So these data are stored somewhere in the website. I mean, in this Chrome browser to help me or to make an intelligent decision so that I don't need to type it again. It is already stored so that I can click it and you can see it. So my data, whatever data that I've searched, my data has been stored. So the users or user information has been stored. That is called as stateful system, where the users previous state, present state, everything is maintained. It's called a stateful system. Guys, समझ में आया या कि एक और बार रिपीट करूं?
समझ में आया सर. समझ आ गया सर.
समझ आ गया? Okay. That is called as stateful system, where cookie plays a major role. Okay. So next one is called as stateless system, where no user data is recorded. Okay. So it is a situation where you open up a incognito tab. For example, if I open up an incognito tab, okay, if I go and click here, you can see that nothing is being displayed here. Okay, when I click here, nothing is displayed, right? Because the cookie is not getting stored in incognito mode. So when the cookie or respective user's data is not stored, it's called a stateless system. You're able to understand, guys, what a stateless system is?
Yes sir. Yes sir.
वापस रिपीट करूं क्या? कुछ मतलब समझ में नहीं आया क्या?
समझ में आया सर.
Okay, cool. So this is the difference between the stateful and stateless system. Okay, guys.
Okay, sir.
Any doubts so far in this today's class till now we had? Hello, guys. Now you people can speak openly so that I need to know, right? So that I can improve myself for the next class. Was
All
the session
clear.
good, guys? Hello.
Yes sir.
Was the session good, guys? You're able to understand? Or do I need to go slow? Anything? Any feedback, guys?
No, sir. It is good, sir.
Okay. Okay, guys. I'm creating a new MCQ now. You try to answer that MCQ, guys. I have created the third MCQ. Just try answering that, guys. Okay, cool. So the very first MCQ that I gave, increasing the GPU is an example of what? So I can see that few people have answered it wrongly. They have answered as horizontal scaling. See, in terms of horizontal and vertical scaling, horizontal scaling is something where So horizontal scaling is something where you add computing units like GPU, CPU, RAM. You keep on increasing the computer's ability to work faster. So that is called as vertical scaling. Sorry, that's called as vertical scaling. So a few people have answered it wrongly. So you people are able to understand now, right? What is horizontal and what is vertical? Vertical is where you keep on increasing the RAM, CPU, GPU, these things in order to maintain it. So I'm just flashing the diagram once again so that you people are able to understand. So increasing the instance like RAM, CPU, GPU, that is called as vertical scaling. And horizontal scaling is where you create a lot of other, you add more computers. You don't increase the ability of that one particular computer. That is called as horizontal scaling. Okay. Yeah. And yeah, one more MCQ I'm giving, guys, the fourth MCQ for today. Yeah, guys, I have added the fourth MCQ. Please answer those. Okay, there are few people who need to answer the MCQ. Please do it fast. Only 50 seconds are there. Okay, guys, seems like everybody has answered it correctly, the other MCQs. Cool, guys. So just to iterate it again, I'll just move to the topics that we wanted to discuss. So we were able to cover up all the topics that we planned for this particular session. You are really a wonderful audience. I was able to go through all the topics with you guys. So if any one of you guys has doubt or anything that you want to discuss with me, I'll be available after the session also for 5 to 10 minutes. So if you want to discuss it separately, we can discuss. Any other doubts or anything, guys, that you want to ask me now here?
सर कल से HTML स्टार्ट करेंगे क्या?
नहीं, और सिस्टम डिजाइनिंग में और एक दो लेक्चर होगा, उसके बाद फिर हम HTML स्टार्ट करेंगे. Probably, I guess Wednesday, Thursday, Friday we will start HTML, I guess.
सर थ्योरी है क्या सर?
क्या बोल रहा है, मतलब HTML थियरी पूछ रहे हो या फिर सिस्टम?
नहीं, ये सिस्टम डिजाइन में.
हाँ, सिस्टम डिजाइनिंग ज्यादातर थियरी रहेगा, ज्यादातर थियरी होगा. सी एक चीज याद रखो गाइस, whenever you enter go to when you join a company, right, you will be like an associate developer or a software engineer 1 2 3. That's how you'll go. Then you become a senior software engineer, then you become tech lead, then you go to architect. So this is the path you will follow mostly. Okay, so this system designing concept initial days में आपको मतलब ज्यादा मतलब it will not come a lot, but once you start working with the database, the backend, right, at that time this efficiency, scalability things comes a lot. तो मतलब ये theoretical knowledge थोड़ा जरूरत है आप लोग के लिए. During the interview, right, during the technical interviews, there is a high chance that you might get questions from here, for theory questions from here. Okay, so I'd suggest you guys to learn this concept at least, मतलब थोड़ा अच्छी तरह से पढ़ लो ये सब concepts. Okay. Hello.
Yes sir.
Okay.
Yes, sir.
Okay. I guess you guys are waiting for the HTML, CSS part. I mean, coding part, right?
जी सर, इसमें है ना ज़्यादा बोरिंग लगता है थियरी में।
अच्छा, okay, okay. आज क्लास बोरिंग था क्या?
नहीं सर, ऐसा बोरिंग नहीं था, बट थ्योरी है ना, पढ़ने के लिए मन नहीं करता है, स्कूल जैसा
हाँ,
लग रहा है।
हाँ, that's true, that's true. बस मतलब एक और 2 दिन की बात है. And after that, will be in full time coding only, guys. Don't worry. So you guys know any programming language? I mean, you guys have learned any programming language before?
Only Python, sir.
Okay, you guys know Python. Okay. So in Python, the basic stuff you know, right? I mean, how to write a basic program, loops,
Yes, sir.
then if else, like that. That things you guys know, right? Everyone?
Yes, sir.
Okay, okay, nice. So HTML would be a bit different as compared to Python. Then I think after HTML, we'll go to CSS, then JavaScript. JavaScript is really good language, man. It's a very, very good language. I mean, it's kind of a little bit tough, but if you are able to learn JavaScript very well, right, you have a lot of opportunities. You have a lot of job. I mean, you can appear for n number of interviews. JavaScript, Python, these things are really powerful today. Then after that, I guess you have React in your course or Angular in your course. Which one you have in your course?
React.
React, right? So React is an library of JavaScript, which is really it's. I mean, today, right? If you walk into a company, if you see, right, if 10 positions are open for a software engineer, out of 10, you will see around 5 to 6 openings will be for React and Node.js, like that. So it has a good demand in market today. So I think you people have chosen a right path now. You people can go higher. Okay. Yeah, guys, that's all about for today's session.
React,
Yeah.
Angular और Vue तीनों में difference क्या है दादा?
Okay, देखो, there is some concept called as framework and library. Okay, framework is something which has everything from there's a new concept called as, in modern web development we have one concept called as MVC, where MVC, so which is view, then you have controller and model. Okay, so Angular is a framework where everything is present, but React and Vue are something like only you will be able to see only the view part is captured there. Other thing like state management, these things are not present. I know these might be very big terms to you guys now, but don't worry. I'll in further when we approach HTML, CSS, JavaScript, right, and React, right, at that time I'll explain this clearly. But the difference is Angular is very, very heavy and React is very, very light. That is the difference. In the Angular application, you can import React package and you can write React code like that. So React is very, very lightweighted. You got it, guys? I mean, the person who asked the question.
Yes, sir.
Okay. Okay, guys. You guys are a wonderful audience. Any other questions, you guys? You guys have any other question? Sorry?
Have you created any attendance?
Oh, okay. I haven't created that. Then okay. I'll just do that. Okay. Okay, 1 minute. I'm just creating attendance. Yeah, I've created the attendance. Seems you're able to see the feed, guys.
Yes, sir.
Okay. So you guys are filling up the attendance now. Yeah, guys, that's all about today's session. Do you want me to send this PPT to you guys? You want this PPT to study or something?
Yes, sir. Yes, sir.
Okay. Okay, I'll just search a way. I mean, I'll ask the other instructors that how do they send these materials. I'll get to that and I'll send it back. Okay.
They send via GitHub, sir.
Okay, send via GitHub. Okay.
और रीडिंग मटेरियल का भी ऑप्शन आता है ना डैशबोर्ड में।
Okay. हाँ, reading material का है. Okay. I'll upload it there. Don't worry, guys. Okay. Thank you guys for today's session.
Okay,
Let's
sir.
meet
Thank you, sir.
tomorrow.
Thank you,
Thank you,
sir. Good
sir.
night.
Good night,
Hope you guys liked my session.
Thank you,
As
sir.
we expect. Yeah, good night, guys. Let's meet tomorrow. Bye, guys.
Leave.